When you think of life on Earth, what comes to mind? Green forests stretching toward the sky, oceans glittering under the sun, birds flying overhead. Almost every picture of life we carry in our minds involves sunlight. After all, the sun powers photosynthesis, fuels our food chains, and drives our climate. Without it, we assume life would grind to a halt. But here's the twist. Some of the strangest, most extreme, and deadliest ecosystems on Earth have absolutely nothing to do with sunlight. Hidden in caves, buried beneath miles of ice, or thriving around volcanic vents on the seafloor, these places prove that life doesn't play by the rules we expect. Instead of sunlight, organisms survive on poison, acid, or bare rock. They thrive in suffocating darkness, crushing pressure, or toxic gases that would kill us in minutes. And yet for them, these hostile places are paradise. In today's episode of Hidden Worlds, we're diving into 10 deadly ecosystems that exist without sunlight. Each one challenges what we know about life on Earth, and maybe even beyond Earth. Because if life can flourish in poison caves or in boiling water at the bottom of the ocean, who's to say it couldn't also survive on Mars, Europa, or other worlds hidden from the sun? So sit back and get ready, because we're about to explore the most dangerous, fascinating, and mind-bending places where life thrives in the shadows. So let's get into it. Number 10, Movile Cave, Romania's toxic time capsule. Our journey begins in Romania, near the Black Sea coast, with a cave that scientists call a natural time capsule, Movile Cave. This cave was discovered in 1986 by accident, when workers digging for industrial land broke into a hidden pocket underground. What they found stunned the scientific community. Movile Cave has been sealed off from the surface for more than 5 million years. In that time, its atmosphere and its biology evolved in total isolation, creating one of the most bizarre ecosystems on Earth. For a human, stepping into Movile without protective gear would be lethal. Oxygen levels are only about 7 to 10%, less than half of what we need to breathe. Carbon dioxide is more than 100 times higher than surface levels. And the cave is full of hydrogen sulfide, methane, and ammonia, toxic gases that make the air smell like rotten eggs. But instead of being barren, Movile is teeming with life. Scientists have cataloged more than 30 animal species inside, and many of them exist nowhere else in the world. Blind scorpions scuttle through the dark. Translucent leeches swim in pools of water. Tiny centipedes creep along the walls. These creatures have evolved in isolation for millions of years, adapting to a poisonous world with no sunlight. So how does this ecosystem survive without photosynthesis? The secret lies in its bacteria. Thick mats of microbes coat the cave walls and water surfaces, feeding on the cave's toxic gases. These bacteria perform chemosynthesis, a process that uses chemical energy rather than sunlight to produce food. Just as plants use sunlight to turn carbon dioxide into sugar, these bacteria use hydrogen sulfide or methane. They form the base of Movile's food web, sustaining all the other creatures that crawl, swim, and scuttle through the cave. The discovery of Movile changed the way scientists think about life. It's a real-world example of an ecosystem cut off from the sun, thriving instead on poison. For astrobiologists, Movile is especially exciting because it shows how life could exist on other planets or moons where sunlight doesn't penetrate. If microbes here can survive on sulfur and methane in the dark, maybe similar organisms could live beneath Mars' surface or under the icy crust of Jupiter's moon Europa. One researcher who first ascended into Movile described it as stepping into another world, the walls sweating with condensation, the air choking with sulfur, and strange alien creatures moving in the shadows. To us, it's a death trap, but to its residents, it's paradise. Number 9, Lechuguilla Cave, America's hidden lab. Next, we head to the deserts of New Mexico, to one of the deepest and most mysterious caves in North America, Lechuguilla Cave. For decades, its existence was known only through small, windy passages that seemed unremarkable. Then, in 1986, spelunkers broke through a collapse and entered one of the most extraordinary underground networks ever discovered. Lechuguilla stretches more than 150 miles underground and drops 1,600 feet deep. Its chambers are decorated with surreal formations, gypsum chandeliers, curling crystals, and delicate mineral growths that look like they belong in a fantasy film. But beyond the beauty lies danger. Unlike most limestone caves carved by rainwater, Lechuguilla was formed by sulfuric acid eating away the rock. That means the air and waters in the cave are still laced with sulfur compounds and other chemicals that make exploration hazardous. But what really makes Lechuguilla special is its microbes. In 2012, scientists sampled bacteria from the cave and made a shocking discovery. Many of these strains were resistant to modern antibiotics, including some of our strongest drugs. How could this be when the cave had been sealed for millions of years untouched by human medicine? The answer is that antibiotic resistance is an ancient trait. In the microbial world, bacteria have been waging chemical warfare against one another for hundreds of millions of years. Lechuguilla's microbes had already evolved defenses long before humans invented penicillin. To scientists, this was both fascinating and concerning. It meant that antibiotic resistance is not just a modern problem caused by overuse in hospitals and farms, it's baked into the very fabric of microbial evolution. For explorers, Lechuguilla is dangerous not only because of its toxic gases, but also because of its sheer remoteness. Reaching some of its deepest chambers requires days of underground travel, navigating razor-sharp rocks and squeezing through passages barely wider than a body. Yet for science, this cave is priceless. It's a natural laboratory for studying geology, microbiology, and the very limits of life. Number 8, Frasassi Caves, Italy's sulfur rivers. In central Italy, beneath the Marche region, lies the Frasassi Cave system. To tourists, it's a place of breathtaking underground cathedrals filled with stalactites and stalagmites. But beyond the scenic tours, the cave hides one of the most extreme ecosystems in Europe. Here, rivers flow with hydrogen sulfide, a gas so toxic it can knock a human unconscious in minutes. When this gas reacts with oxygen, it produces sulfuric acid, which carves the limestone into vast chambers and jagged passages. For us, it's a death trap. For microbes, it's an opportunity. Frasassi's walls are covered in white, fluffy mats of sulfur-oxidizing bacteria. These microbes form the foundation of an entire food web, supporting worms, insects, and other cave-dwelling creatures. The system doesn't rely on plants or sunlight, but on chemical energy drawn from poison. To scientists, Frasassi is like a window into early Earth. Billions of years ago, before plants filled the atmosphere with oxygen, life may have depended on sulfur cycles just like this. Number 7, Cueva de Villaluz, Mexico's acid drip. Deep in Tabasco, Mexico, lies a cave that looks like something out of a nightmare, Cueva de Villaluz. Its springs are rich in hydrogen sulfide, and the air is heavy with toxic fumes. Hanging from the ceilings are bizarre formations called snotites, slimy microbial colonies that drip sulfuric acid. Some droplets are so acidic they measure near 0 on the pH scale comparable to battery acid. Yet, life thrives. Microbes feed on the hydrogen sulfide and build entire mats of living slime. Other organisms, from insects to fish, feed on them, creating a food chain built entirely on poison. For scientists, Villaluz is both fascinating and dangerous. Exploring it without protection risks chemical burns, suffocation, or worse. But its snotites are a reminder of how creative life can be, finding nourishment where we see only destruction. Number 6, Crubera Cave, Earth's deepest descent. Far from the warm caves of Mexico, we now descend into the icy depths of the Caucasus Mountains. Crubera Cave, also known as Verona, is one of the deepest known caves on Earth, plunging more than 7,200 feet into the ground. For explorers, it is one of the most challenging environments ever attempted. At these depths, oxygen becomes scarce, while carbon dioxide builds up in lethal pockets. Water from underground rivers chills to near freezing, and passages narrow to claustrophobic squeezes. Diving teams exploring Crubera have to use special gas mixtures to avoid suffocating. Despite these conditions, microbial life has been found clinging to the cave walls. Using chemical energy from minerals like iron and manganese, these extremophiles survive where no sunlight can reach. For humans, Crubera is a hostile descent into darkness. For microbes, it's just another home. Number 5, Abyss of Hranis, the drowning pit. In the Czech Republic, the Hranis Abyss holds the record as the world's deepest flooded cave. Divers have reached depths of over 1,300 feet. but sonar suggests the cave may plunge far deeper, 1,700 feet. Its waters are saturated with carbon dioxide, making it a suffocating trap for anyone who descends unprepared. Yet even here, microbial life thrives, living off dissolved minerals in the water. The abyss is both a danger to explorers and a living laboratory for extremophiles. For astrobiologists, it's another clue that hidden oceans on icy moons could harbor life, even in suffocating conditions. Number 4, lava tubes, Hawaii's Martian mirrors. In Hawaii, the remnants of ancient volcanic eruptions form long, hollow tunnels called lava tubes. Inside, it's pitch black, sharp-edged, unstable, and sometimes laced with toxic gases. Yet microbial life thrives on the basalt walls, literally eating rock for energy. NASA studies Hawaiian lava tubes as analogs for Martian caves. If microbes can survive in the darkness here, living off minerals, then similar life could exist under Mars' surface. For humans, these tubes are hazardous. But for extremophiles, they're a model of resilience, and perhaps a preview of extraterrestrial life. Number 3, Naica Crystal Cave, Mexico's scalding tomb. Beneath the Naica mine in Chihuahua, Mexico, lies one of the most breathtaking and deadly caves on Earth, the Cave of Crystals, or Cueva de los Cristales. Temperatures reach 136 degrees Fahrenheit, or 58 degrees Celsius, with humidity near 100%. A human without protective gear would collapse within 10 minutes. But the cave is filled with gigantic selenite crystals, some over 30 feet long. Even more astonishing, microbes have been discovered trapped inside fluid inclusions within the crystals, potentially surviving for tens of thousands of years. Revived in the lab, they showed that life can persist in scalding, isolated environments that seem utterly inhospitable. The Naica Cave is both a dazzling wonder and a lethal trap, a reminder that beauty and danger often go hand in hand underground. Number 2, hydrothermal vents, black smokers. At the bottom of the oceans, far from any sunlight, hydrothermal vents spew superheated water filled with toxic metals and hydrogen sulfide. These black smokers reach temperatures hot enough to melt lead. Yet life thrives here. Giant tube worms, blind shrimp, and crabs gather around the vents, supported by bacteria that use chemosynthesis to turn poison into energy. Hydrothermal vents may even resemble the conditions where life first began on Earth 4 billion years ago. For humans, these vents are instant death zones. But for the creatures that call them home, they are thriving metropolises, perhaps the closest thing to alien worlds right here on our planet. Number 1, Lake Vostok, Antarctica's alien ocean. Our journey ends in Antarctica, under 2.5 miles of ice. Lake Vostok is one of the largest subglacial lakes in the world, about the size of Lake Ontario in North America, sealed off for at least 15 million years. No sunlight penetrates. The pressure is immense and the waters are locked away from the atmosphere. Despite this, genetic evidence suggests microbial life exists in the lake. It's home to organisms such as bacteria, fungi, and eukaryotes like water fleas and mollusks. For scientists, Vostok is a potential blueprint for life beneath the icy crusts of moons like Europa and Enceladus. But entering the lake comes with risks. Ancient microbes sealed away for millions of years could pose unknown threats if released. Lake Vostok is a reminder of how much of Earth remains unexplored. It is a hidden ocean, alien in every sense, right here on our planet. So what do these hidden worlds teach us? They remind us that life is far tougher, stranger, and more adaptable than we imagine. It doesn't need sunlight. It doesn't need warmth. It doesn't even need oxygen as we know it. From caves dripping with acid to lakes sealed beneath ice, life has carved out a way to survive. And if it can do so here, why not elsewhere? Maybe under the ice of Europa. Maybe in Martian lava tubes. Maybe in places we haven't even thought to look. For us, these ecosystems are deadly. For the organisms that inhabit them, they are paradise. That's the wonder of life. It adapts, it persists, and it thrives in the most unexpected places. Which of these ecosystems fascinated you the most? Let me know in the comments below. And if you enjoyed this journey underground, don't forget to subscribe for more dives into the hidden corners of our world here on Betcha Didn't Know Hidden Worlds. Thanks for watching.